Okay, so in this video here, I'm going to show you how to set up a kinetics apparatus for Lab 2. All right, so the first thing we do is we get out our MicroLab interface here. We have to make sure we have a cord, both a power cord and a cord to interface with the computer, USB cord. All right, so we take these, we find ourselves a spot here at a computer. All right, so our MicroLab interface here, we have to make sure that the power cord is plugged in. We want to make sure that the power cord here is plugged in as well, right? Make sure that our USB plug is plugged in. We have to make sure that our power is on here. All right, the light over there tells us that the power is on, okay? Then we're going to make sure we plug in our USB cord here that's wound around a little bit. All right, there we go. Plug in our USB cord. There we go, make sure we still got power. All right, everything's good. And then we're going to log on to the computer here really quick. Okay, so while that's going, we'll go and get the other parts necessary for this lab. All right, so this is the kinetics lab. We're going to be after monitoring the pressure. Okay, so to monitor the pressure, we need to have this drawer down here, which says syringe. Okay, so we're going to take one of these syringe apparatuses here. All right. So this apparatus there has a syringe, it has a needle going through the syringe, it has a cork, there's a plastic or a glass tube going into the cork, and then the end of this has to have this kind of a fitting to go into the end of the MicroLab, the sensor on the MicroLab. Okay? So I grab one of these. I can also pick up a ring stand. All right, so I'm also going to need a stir plate. I'll plug in the stir plate. Okay. All right, so we have the stir plate there. This is going to be used to hold the bottle still. We need a vessel, whoops, a vessel that is not too large, because the end of the vessel needs to be able to fit into this cork right here, this cork. So we need to go and get that. All right, so we got ourselves a 25 milliliter Erlenmeyer flask, and we're going to put the flask into this pinch clamp here, or this 3-prong clamp. And then our cork has to be able to make sure it's going to be able to seal well. The pressure sensor right there, you can see where it says pressure, that's the spigot for the pressure sensor. We screw it down, make sure it's nice and tight here, make a good seal. This needs to make a good seal. This around here needs to make a good seal, obviously. This needs to be closed. If it's open, perpendicular is closed, parallel is open. If it's open, then the pressure is open as well, right? Okay, so we get onto the computer here. We're going to open up our MicroLab software. In the MicroLab software, we're going to, first of all, we have to wait for this bar right here. If it doesn't say reading from flash memory, then that means you don't have it plugged in or hooked up correctly yet. So we can go to MicroLab experiment. We're going to add a sensor. The sensor that we want to add is a pressure sensor. This is where we plugged it in at. We say next. And then we go to calibrated factory ATM. So atmospheres are the units we're going to use in this lab. And this is factory calibrated. Essentially, you just plug it in and choose the software or the electronic file that it's going to use to calibrate it. So you don't have to do any actual physical calibration here. Then you say finish. We're going to put the pressure sensor on the y-axis because that's what we're monitoring. We need to add one more sensor. We need to add a timer so that we can monitor pressure versus time. All right. Seconds is fine there. And we'll put the timer on the x-axis here. All right, we can put the pressure over here, and we can put the timer over here too. And the pressure is reading 0.982, which is fine. The pressure should be around 1, something around 1.0. So 0.982 is fine. It really doesn't matter what the absolute pressure is or the difference between it and your neighbors, for example. What's important is the change in pressure over time, and that's what we'll monitor. Okay, so we have everything set up and ready to go. Now we just have to start putting into here different amounts of our reactants. Hydrogen peroxide is one of your reactants. You're going to have different catalysts, or not different catalysts, but you're going to have different volumes of the hydrogen peroxide, different buffers, and then equal amounts of catalyst. All right? So that chart is on the lab, and we'll look at that now. So there's our lab 1. Here's our lab 2. Okay, so these are the experiments I'm going to run. I'm going to add 6.8 milliliters of water into my container there. Okay, now to do that, what I do is I take this off, and then I just add the 6.8 milliliters of water right into there. So 6.8 milliliters of water, 0.2 grams of potassium iodide. Again, I just weigh out the 0.2 grams and put it right into there. I have to make sure, if I want, I could do the 0.2 grams first and then use the 6.8 to rinse them in there. But I need to make sure that I don't put extra water. The ultimate volume of these reactions needs to be consistent, constant, the same. So then, after I have my water and my potassium iodide in there, I'm going to get ready to put in the hydrogen peroxide, but I'm not going to put it in yet. So in this first experiment, I need to put in 3 milliliters of hydrogen peroxide. 3 milliliters of hydrogen peroxide, okay? So after I have put in the water and the potassium iodide in there, another thing I need to have in there is a stir bar, because if I put the potassium iodide in there and also the water and ultimately the let's see, that's the heater. Don't want the heater on. We want the stir on, okay? So I need to have a stir bar in there to make sure I mix up the potassium iodide and the water well. And so after I have my potassium iodide and my water in here, then I can use this cork here and seal it down nice and tight. So I can, after I have the water and the potassium iodide in there, I can put this down, seal on nice and tight, and I can keep this closed like that, and then I can unscrew this syringe, just the top part of the syringe here. All right, so I got this off, and now I can use this to deliver my volume of alcohol, all right, or of hydrogen peroxide. So I need to deliver, like it says here, 3 milliliters of hydrogen peroxide. So I'm going to fill this up to 3 milliliter mark with hydrogen peroxide. All right. After I fill it up with 3 milliliters of hydrogen peroxide, I put it back on to the valve here. I don't want to take the needle in and out, because if I do that, then it's hard to get back in, and you risk bending the needle and also pulling the cork out and such. Okay, so I have my hydrogen peroxide then that I would be ready to inject, right? Then I need to go back to my microlab page here, and at this point, before I've injected anything, I need to start the experiment. So I push start, and it goes monitoring pressure versus time, right? So the pressure points are being taken right down here, it says repeat every half a second. So it's repeating it every half a second, and that's fine. All right, so the pressure is staying constant. And then as I am ready to go now, I have the program running. I open up my valve, all right? and then I inject my hydrogen peroxide, and I keep the top down, and I need to close the valve, and you'll have two hands, so you'll be able to do it quicker, but you want to keep the pressure in there. Now, that injection, you'll see, just because of that injection, I got a little bit of an increase in pressure there. And that's not the increase in pressure that we're after, but this will be our time zero right at the injection there. So that's where the reaction begins, and then as the hydrogen peroxide begins to break down, this line here would gradually increase, and as it gradually increases, we're getting our rate, how much pressure is being produced versus time, and that's kinetics. We're getting the rate, how fast it's going is related to the slope. If it goes really fast, if the pressure increases very fast, then this is going to be a sharper slope, a higher slope. All right? Okay, so that's how you set up your apparatus there. That's how you set up the software. After this value stops rising, maybe it levels off or it begins to go down a little bit, then not just the value, but the slope, right? Because the slope slowly increases and then it gradually levels off. As soon as you see it begin to level off, then you can stop the experiment. Okay? So that's how the experiment will be performed. All right, so now we're going to run one of these experiments. I'm going to run the top one here, 6.8 milliliters of water, 0.2 grams potassium iodide, and then 3 milliliters of hydrogen peroxide, 3% hydrogen peroxide. All right, so here I have my 3% hydrogen peroxide, I have my water, and I have my potassium iodide. Okay, so I'm going to take this off here. I'll go to this software here and push stop. I was running an experiment before, so I'm not quite ready to, I'm going to repeat the experiment. I don't need to save the data this time. All right, so I'm not quite ready to push start, but the software is all ready for me when I'm ready to push start. Okay, so I'm going to add the water first. First I'm actually going to try to add the potassium iodide straight like this, because the potassium iodide can get kind of sticky, and you can see how we might need to add a little bit of water into here to dissolve some of the potassium iodide. Okay, and you can, with two hands, put the potassium iodide, or put the water into the vessel more carefully and make sure you get all the potassium iodide in. Okay, now I have this thing here. I can put the lid on. I don't care about containing the pressure at this point. I mean, when I push the cork in, that will kind of alter the pressure a little bit. So if I have this thing off, if I have this thing off and this thing open, then when I push the cork down, it won't increase the pressure on me, right? It'll just keep the pressure the same. All right, so now I have a nice good seal there. Okay, nice good seal. The experiment that I'm trying to perform right now is the one that has 3 milliliters of hydrogen peroxide, correct? If I wanted to perform the ones that were lower, like 1 down to 0.2, right, then I would actually want to use this syringe here, which is a 1 milliliter syringe. That way 0.2 I could measure accurately enough like that, right? Whereas this one wouldn't be very good for measuring 0.2. All right, but the larger one I want to use for the first experiment, right, from 3 down to 1.4, right? So the first half I'm going to be using this larger syringe here. Okay, so I'm going to get my 3 milliliters of solution of hydrogen peroxide. Okay, and this can rest right here for a second. I'm going to make sure that this is closed so I don't accidentally insert a little bit of hydrogen peroxide in there. All right, so now it's closed. This is sealed. I can screw this on, and now it's ready to dump into the vessel, which has water and the potassium iodide. Now I can go back to my program, my experiment here, pressure on the y-axis, time on the x-axis, and I can push start. Okay, I'm going to push start, and now it's going to start monitoring pressure again. All right, pressure versus time, about 0.983. All right, so here I go. I'm going to open up this again. Ugh. There we go, better to use two hands. All right, and then I'm going to push this down, and I'm going to actually use two hands for this because, so I open up the valve, right, push it in, get it all in, and then close the valve, okay? And then I see a little bit of a color change there. I see the initial pressure increase. That pressure increase is due to just adding the hydrogen peroxide, right? So it's not to the hydrogen peroxide decomposition. But I can see gradually, slowly, I'm getting an increase in pressure. So this value is increasing gradually. The slope is increasing. All right, I'm up to 1.110, 1.119, right? So I'm gradually increasing. And it's not this ultimate value. I'm not trying to get to a specific point here as much as I'm trying to see how fast the reaction can perform, the rate of the reaction, and that's measured by the slope of this line. All right, so I just allow the vessel to continue, and you can look down in there and you can see there's a certain amount of gas that's being produced. All right, the oxygen that's decomposing there. All right, sorry, the hydrogen peroxide that's decomposing and producing oxygen. And now we just wait and let this go until one of two things happens. One, we don't want to go above 2 atmospheres. So 2 atmospheres is our limit. The second thing is if the rate of increase stops, right? So if the slope begins to come back down again. And it looks like it's, let's see, is the slope still increasing? It's hard to say. It looks like it should be pretty linear for a while. It might be decreasing a little bit already, but it should be pretty linear. Okay, so we let this go for a while, and then we take the data and we'll analyze it, and we'll have a quick segment on how to analyze the data. Okay, so we can see our experiment is still running, and the pressure is increasing still, but the rate of increase has decreased, and we can see that because it increased here and then it began to curve over, right? So it's gradually decreasing now, the rate of reaction, and the rate of reaction is decreasing because the amount of hydrogen peroxide is limited, okay? But what we're interested in is the fastest slope between the time 0, which is when we added the hydrogen peroxide. That's that big jump. We're not interested in the slope of that little tiny bit, but we're interested in the fastest slope that there is in this experiment between here and the end, and usually that's going to be within the first 200 seconds here. Okay, so I can stop the experiment now. All right, I stopped the experiment and I want to export this data. So I go File, Export Data As, comma separated values for text file for Microlab. Okay, and then it says where do you want to save it. I'm just going to put it on the desktop here. I'm going to call this my first experiment, experiment 1, and then I'm going to say save. Okay, so looks like it's going to open it for me here. I highlight the 2 columns, insert a scatter plot here, but I'll just use the line there on the scatter plot so I don't have to have the line so thick. Okay, now this is a fine graph, and I would like to know the slope of this graph. All right, so the first thing you do is you can just take visually and look and see where it looks like the fastest slope is. And it looks like this region in here has the fastest slope. Although if you were to extend it out to here, it probably wouldn't affect the slope very much. So if you were to take this region, it'd be fine. It'd be very similar to this region and very similar to this region. So it's not terribly important where you take the slope. You do try to want to be a little bit consistent, but if you're a little bit off from run to run in terms of the region that you take the slope, it'll be okay, as long as you find you're always aiming for the fastest slope that you can find, the steepest slope, right? The fastest, I say fastest because this is a kinetics experiment where oxygen is being produced and being measured by the pressure that's being produced versus time. Okay, so it looks like this region is a good region for me, from maybe about 80 seconds to 112 seconds. All right, so what I'm going to do, I like to split the screen here, and then I can, I don't need to split it vertically, just horizontally. So then I can use this, and I can scroll down to my 80 to 120 second range. So somewhere around in here, 81 seconds, I'm going to drag down to about 120 seconds. I'm going to insert another graph. Same thing, there's my graph there, okay? So now this is a little segment of that graph right there. It looks like a different slope, looks completely different because the axes values are different, it's zoomed in, right? If I right click on this and I add a trend line, right, then I can display the equation on the chart. That's all I need to do there. I want to right click here and I want to format that trend line label and increase the number. How do I do that? Oh, it's a number. How many decimal points? Let's go out to like about 6 decimal points. There. Push enter. And so this slope is the atmospheres versus time. So it's 0.001958 atmospheres produced over time. We go back into here, we see that there's 4 significant digits. So I should be able to get 4 significant digits out of this, 0.1958, or 0.001958. Okay? Now, I can take this whole graph, copy it. So I copied this whole graph, and I can go up here, and I can push paste on it. And you'll see this little region here, this blue region, is this graph right here. And this slope right there is the slope of that right there. All right? So this, I'm going to drag this window down a little bit for a second so I can just look at the top graph I've made here. This is a good graph. I mean, I have to put the labels on, obviously. But this is, and here, let's also format the axis over here. We don't need it to start at 0. It can start at about 0.8. as the minimum axis, right? To kind of expand our region of view here. All right, so this is a good graph showing the complete experiment and also showing kind of the area of the fastest rate. And that rate is 0.001958. And that value is the value that I'm going to want to put into this rate in atmospheres per second. 0.00, what was it? 1958, right? So I can write that into my lab report there, 0.001958. And you're going to have to later convert that into moles per second using pervnert, assuming that the gas that's produced here is related to all the moles of oxygen gas, right? I notice my atmospheres are getting a little bit high here on my pressure sensor. So I'm going to turn it off, or to release the pressure. And you know, there's a couple ways to release the pressure. If you undo this cork, you might get a little spray here. If you undo this, then this thing might pop out. So if I just kind of slowly open up this valve here, all right, so there I've released the pressure, and I see my pressure has gone down to 0. So that's a nice, safe way to release the pressure. Now I can undo this cork and not have anything spray on me. Okay? So I can take this, put it in the appropriate waste container, and then also wash it out well and prepare it for the next experiment. Okay? After I have that value, 0.001958, I'm going to want to start plotting these values, 0.001958 versus, so this is the rate, and this is the rate again in pressure, atmospheres per second, and we have to get it eventually to moles per second. But I'm going to plot those rates versus the concentration of hydrogen peroxide. Now, I'm not going to tell you the the concentration of hydrogen peroxide, you have to kind of go through that calculation yourself. We want to, whoops, H2O2. We want this to be in molarity. We want the concentration of hydrogen peroxide to be in molarity. And right now, we know that our stock is 3% hydrogen peroxide. 3% means 3 grams of hydrogen peroxide for every 100 grams of solution. And we can assume the density of the hydrogen peroxide is 1. But what is the ultimate concentration of hydrogen peroxide in here? And what is its in molarity? Because we want it in molarity. Okay? So we have this, we're going to get multiple rates, right? We're supposed to do the experiment 10 times here. We're going to get 10 different rates, and we're going to get 10 different concentrations, and then we're going to plot those 10 different rates and 10 different concentrations